Hello, and welcome to the KC4 Test Part 2 review. All right, the first thing that we're going to do is solve some equations. When I look at an equation, the first thing I like to do is split it down the middle with a line. I know that's generally how we are taught in middle school these days, so I want to do that to keep it kind of consistent. Also, I kind of like the visual aspect of it. All right, so when you think about solving equations, we're trying to get x by itself. That's the goal. So when I look at the left-hand side of the equation, I see that the x is attached to the 9, but the 9x is attached to the minus 7. So the first thing I want to do is take that minus 7 and move it away from the 9x. So I can only get x by itself on the very last step. So I need to get that 9x by itself so then I can make that 9 go away. All right, so let's think about it. The minus 7, how would we undo minus 7? We would add 7 to both sides. So let's do that. Plus 7 plus 7. And what I mean by both sides is both sides of the equal sign or both sides of that line that we drew. The whole concept of having an equation with an equal sign is that you do the same thing to each side because that's what being equal is about. All right, on the left-hand side, the minus 7 and plus 7 cancel. That was kind of the point. So all we are left with is 9x. I rewrite the equal sign in the middle. Negative 7 plus 7 is 0. So that's the number I write down. Okay. One last step to get x by itself. 9x is actually 9 times x. So think about it. How would we undo multiplication? We would do division. Let's do that. So divide both sides by 9. Beautiful. I know to divide by 9 because that is the number that's attached to x. On the left, the 9's are out, so we are left with x equals 0 divided by 9 is 0. X equals 0. Okay, number 2. All right, the first thing that I'm doing, once again, is drawing that line down the middle. Okay. Now, when I look at the left-hand side of this equation, what I notice right away is that I have two sets of x's. So I am going to combine like terms. Combine LT, like terms. And the like terms that I am about to combine are negative 15x and a 5x. I can combine them because they are both x's. All right, negative 15 plus 5 is negative 10. So we have negative 10 x's. And I know to do that operation in between them because they're on the same side. If they're on the same side, you do exactly what is written in between them. So I have negative 15x and a plus 5x. Now I just bring down the plus 21 because I didn't do anything to it. I bring down the negative 19 because I didn't do anything to it either. And I don't forget to rewrite that equal sign in the middle. All right, so our goal is still to get x by itself. So the x is attached to negative 10, and the negative 10x is attached to the plus 21. So let's get rid of that plus 21 first. How do we undo addition? We use subtraction. So I'm going to subtract 21 from the left and from the right. Remember, we have to do it from both sides because that is what an equation, what an inequality is. You got to keep it equal. Got to keep it balanced. Plus minus 21 on the left cancel out, and we're just left with negative 10x. Be very careful not to drop that negative. And on the right-hand side, we have negative 19 minus 21, which gives us negative 40. Now be very careful when entering this in your calculator or when just thinking about it. When you're subtracting, there should only be one minus sign between that. It's not negative 19 minus negative 21. It's just negative 19 minus 21. Okay, last step. Negative 10x is negative 10 times x. So how would you undo multiplication? That's right, division. Let's do it. Divide both sides by negative 10. Whoops, I don't know. That looks like 110. My finger must have hit something. I know to divide by negative 10 because that's the number attached to x, and I'd like to get x by itself. On the left-hand side, the negative 10s are gone. I'm left with x equals negative 40 divided by negative 10 is positive 4. Oh, I forgot to write that we divide right here. Div. Onwards we go to number 3. I'm just going to zoom out a bit and scroll over. Ooh, fractions. Don't worry, fractions aren't too bad, especially since we have our calculators. All right, so in an equation, first thing I want to do is split it in half for the nice visual effect. What do you think the first step should be? The first step should be adding 7 to both sides because that's the opposite of subtracting 7. And that is the first step I want to take here. Don't forget to add to both sides. On the left-hand side, the minus and plus 7 cancel, and we are left with 3 over 4 x equals 21. Okay, now please think about it. How would we get rid of that fraction? Okay, the way we would do it is we'd multiply both sides by its reciprocal, meaning we multiply both sides by that fraction flipped upside down. And the reason we do that is dividing both sides by a fraction is the same as multiplying by that reciprocal. And if you're thinking about, well, in number 1 and 2, when I said there was a number next to x, that means times. Well, yeah, 3/4 x is 3/4 times x. We undo it by dividing both sides by 3/4, but dividing both sides by 3/4 is the same thing as multiplying by 4/3. Okay. On the left-hand side, the 4's on top and bottom cancel, so do the 3's, so we're only left with x. And then 21 times 4/3, so 21 times 4 divided by 3 is 28. Okay, wonderful. Let's continue to number 4. Oh, one a little too far. Okay, so take a look at number 4 and think about what could the possible first move be, except for drawing the line. I'll do that right now. So number 4, what I notice that there are x's in numbers on both sides. My favorite first move to do is to move the x's. Now, you might remember me telling you in class that there are actually 4 different ways to start this problem. So you could start this problem differently. Just make sure you're undoing operations. I'm going to do it my favorite way, which is moving the x's around first. Now, what I'm looking at is the 8x on the left and the 4x on the right. Because the 4x is smaller on the right, I'm going to move it over to the side of the bigger x's. That's just how I like doing that, and there's reasons behind it, but at the moment, just think of it as just Gumin's favorite way. How would I move the 4x to the left? I would subtract it. Because 4x is positive, I undo it with a negative, and a negative is subtraction. Okay. On the left side, 8x's minus 4x's leave us with 4x's. I bring down the plus 6, the equals in the middle. On the right, the 4x's cancel. That was kind of the point. We're trying to move it over. And I'm left with a minus 14 on the right. Be very careful. That minus now becomes a negative. They are interchangeable. Now, since I moved my x's to the left, I'm going to move my regular numbers to the right. Or you can kind of think of it as our previous equations. What's the next step to getting the x by itself? The next step should be subtracting 6. Let's do it. We're undoing the plus 6 by subtracting. So on the left, the 6's cancel. We're left with 4x equals negative 14 minus 6 is negative 20. What is our next step? The next thing we should do is divide both sides by 4. And I know to do that because 4x is 4 times x, and the opposite of multiplication is division. On the left, the 4's cancel. We're left with x. Negative 20 divided by 4 is negative 5. I have a sneaking suspicion I forgot to write down that I multiplied on this side. Yeah, I did. Let's add that in. Pretend that happened already. Mult. Okay. Number 7. Okay, okay, I forgot how many problems I made here. Did I make them out of order? Of course I did. That's fine. All right. Oh no, I just restarted it for some reason. Anyways, enough Gumin talking to herself, and let's go to number 7. The first thing we should do here should be a big giveaway. It's different than every other equation we did. I'm going to draw a line down the middle. Think about it. The first thing we should do here is distribute. And distributing is multiplying. And I'm going to distribute the negative 5 to both the x and the negative 4. So let's write that dist. Okay. So the minus 3x stays minus 3x. However, let's zoom in a little bit. Make my handwriting better that way. I think. Usually. All right. Negative 3x. Negative 5 times x is negative 5x. Negative 5 times minus 4 is positive 20. And it still equals 28. Now there's another step I can take on the left-hand side before I start moving things around to the right. What do you think that is? What we're going to do is combine these like terms. So I'm just going to write LT for like terms. Negative 3x minus 5x is negative 8x. We bring down the 20 and the 28. Now I knew to do negative 3 minus 5 in my calculator because the x's are on the same side. When the x's are on the same side, you do exactly the operation that's between them. Okay, what's our next step? I'm going to subtract 20 from both sides as my next step because I'm undoing the plus 20. There we go. Okay, on the left, the plus 20 minus 20 cancel. Negative 8x is left over. And 28 minus 20 is 8. What's our next step? The next step that I think we should take, and that hopefully you think we should take too, is divide both sides by negative 8. I know to divide both sides by negative 8 because negative 8x is negative 8 times x, and we undo multiplication with division. The negative 8's cancel on the left. Oh, and I knew to use the negative 8 because that's the one that was next to x. 8 divided by negative 8 is negative 1. Right? And our last equation, let's do it. Let's draw that line down the middle. And what should our first step be? If you thought to yourself, distribute, you were right. Let's do it. Remember, distributing is multiplying. So we'll multiply that negative 4 by the x and by the minus 3. Okay. I'm going to rewrite negative 2x because nothing is happening to it. It's just out there by itself. Negative 4 times x is negative 4x. And negative 4 times negative 3 is positive 12. And that all equals 30. What else can we do on that side before we continue on moving things around? If you thought to yourself combining like terms, you're right. Let's do it. Let's combine. I'm a little less lazy. And this one, I'll write combine LT instead of just LT. It'll be nice on the actual answer key I post, don't worry. Okay, so negative 2x minus 4x is negative 6x. I know to subtract in between them because they're on the same side. And if they're on the same side, that means I do exactly the operation that's there. The only time we do the opposite operations are when we're moving it side to side. Okay. What should our next step be? Our next step should be to subtract 12 from both sides. Okay. On the left, the 12s cancel. We're left with negative 6x equals 30 minus 12 is 18. And lastly, what should we do? Divide by negative 6. I knew to divide by negative 6 because that's the number next to x. Well, let's cross the negative 6's off. I'm left with x equals negative 3. All right. Okay, number 1. Oh, instructions first, Gumin. Determine whether each equation has one solution, no solution, or infinite solution. Let's review. One solution, we just get x equals something, like we did in the previous 8 problems. No solution means we get a false statement, something that doesn't make sense, like 1 equals 2. Or infinite solutions, that's when we get a true statement, like 5 equals 5. Well, 5 does equal 5. That's true, and it will always be true. Okay, let's solve this equation and see what kind of solution we get. Let's draw a line down the middle. Okay, what should the first step be here? We should distribute. Okay, let's do it. So we're going to distribute on the left. The right seems like it could stay exactly the way it is. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And it equals negative 3 minus 2x. Okay. Next thing, let's move the x's, because that's what I like to do. I'm going to move the x from the right to the left. So what I'm going to do, well, how would I undo the minus 2x from the right? I would add 2x. Let's do it. Okay, let's cross it off. All right, so on the right, that was the point. I crossed them off. I'm left with negative 3. On the left, negative 2x plus 2x, that's 0. They're gone as well. They're opposites. So we're left with just positive 4. Now here comes the question. Does 4 equal negative 3? Absolutely not. This is false. If something is false, then we have no solutions. Okay, number 2. Let's draw the line down the middle. Oh, that was ugly. Let's try that again. And while I struggle, what is our first step? Our first step should be to distribute. Let's do it. Well, just on the right, because there's nothing really we can do on the left while we distribute. So let's rewrite 35 minus 7x on the left. Okay. Negative 7 times x is negative 7x. Negative 7 times negative 5 is positive 35. Okay, my video, my way. You know how it is. Let's move those x's over. So I'm going to move them from the left to the right. So I'm looking at 35 minus 7x. To undo the minus 7x, what should we do to both sides? Let's add 7x to both sides. Wonderful. Okay. So the whole point was to get rid of them from the left, so I'm just left with 35. On the right, minus 7x and plus 7x cancel each other out, just like they did on the left. And all we have is 35. Does 35 equal 35? It sure does. we have infinite solution. This is my attempt at infinity without turning my computer sideways. Okay. Ooh, word problem. Admission to the fair costs $4.50. Each ride costs you 25 cents. You have $9 to spend at the fair on rides and admission. Express the number of tickets you can buy with an inequality. Okay, so how much do we start off with? Well, I have $9 to start. So that's the first thing I'm going to write down. 9. Okay, I'm trying to write here. I selected the pen. Come on, buddy. 9. All right, now let's think about it. With the money I have, let's just say it's cash. Can I spend more than $9? No. So I'll write a greater than symbol, or I guess a less than, because 9 is the largest that I have. It's on the open end of my inequality symbol, and whatever I spend has to be less than $9. I can't spend more money than I have. All right. Can I spend exactly $9 if I felt like it? Sure, why not? I can spend all my money. It's mine to spend. So I put an or equal to underneath. So I could spend either less than $9 or exactly $9. Okay. Now I had to get into the fair. Admission was $4.50. So let's write that down, $4.50. I cannot get that money back. You have to spend it no matter what. So $4.50. I also, plus, because I also want to go on the ride. And each ride is going to cost me 25 cents. So let's write that as 25 cents per ride. So let's make it an R. And that is our inequality. If we wanted to solve it, we could, but we're not going to. Number 2. Alex got $250 for his birthday. He already spent $40. His plan was to use the money to buy McChickens after school during the school year. Each McChicken costs $1.50. Write an inequality to represent this the amount of McChickens he can buy. Okay, so how much did Alex get for his birthday? $2.50. Let's write that down. Now I'm going to try to do it here. Like this, $2.50. Can he spend more than the $250 he got? No. $2.50 is the greatest he can spend, so it goes on the open end of my inequality symbol. Can he spend all of his money? Sure, why not? It's his money to spend, or equal to. How much money has he already spent that he cannot get back? $40. So we write this $40 because that's spent, that's gone. But it came out of that $2.50. Now his plan is to now spend the rest of his money in McChickens. So plus, how much does each McChicken cost? Each McChicken is $1.50. So let's make it 1.50 M. Let's make that point a little bit more prominent. And that's our inequality. Let's practice solving them. We got 2 problems solving inequalities. Let's do it. Now, solving inequalities is pretty much the same as solving equations. The only difference is, 1, it's not an equation, it's an inequality. There's another difference. We can graph it on a number line with some arrows. I guess we can graph an equation on a number line, but it'll be just a dot. So it's kind of sad to graph it on a number line. And the other rule is, if we ever happen to multiply or divide by a negative, the symbol, the inequality symbol, has to face the different direction. We have to flip it. Okay, so I'm going to get this started by drawing a line down the middle, just like I do with solving equations, because inequalities, we still have to do the same thing to each side as we solve. Okay, so what's the first step into getting x by itself on the left? I'd start with subtracting 5 from both sides. On the left, the 5's cancel. I'm left with 6x. I subtracted, so my inequality symbol stays the way it is. And 35 minus 5 is 30. Okay, what should we do to get x by itself now? Let's divide both sides by 6. Okay, on the left, the 6's cancel. I'm left with x. I divided by a positive number, so my symbol stays the same. 30 divided by 6 is 5. Let's graph it. Now, when we have a symbol like this or like this, we use an open circle on our graph. When it has a line underneath, we use a closed circle. So for this problem, we're going to use an open circle on positive 5. And then we need to point an arrow because inequalities, it's not just one answer. It's every number that's larger than 5. That's what this solution says. X can be anything as long as it's larger than 5. Which direction is bigger than 5? To the right or to the left? Well, on the left, I have numbers like 4, 3, 2, 1, 0. Those are smaller. So I'm going to point my arrow to the right because it has numbers like 6 and 7. The way I remember this when I was a student and still use it to this day just in my memory banks, and I tell it to my students all the time, less is left. So if it's greater, it's got to be to the right. All right, let's solve number 6. We put a line down the middle. What should your first step be to getting x by itself? I would begin by subtracting 7 from both sides. Okay, let's write subbed. Okay, on the left, the whole point is to get rid of 7, so they're gone. I'm left with a negative x. I subtracted, so my symbol stays the same. That doesn't influence it. 10 minus 7 is 3. Now we're almost done. You don't see a number around x, but it's there around. Next to, I think that distracted me. I don't see a number next to x, but it's there. The number that is next to x is actually an invisible 1. It is implied that if there's no number, oops, that's not what I meant to do. There we go. It's implied that if there's no number in front of x or in any variable, any letter, that there's a 1 in front of it. If there's just a negative symbol, it's implied there's a negative 1. Now you don't have to write it in, but I am reminding you that that 1 is technically there. So what we're going to do to both sides is divide by negative 1. And here's that weird new rule about inequalities. On the left, oh, that's not weird. On the left, the negative 1's cancel and the x is remaining. The weird thing is now the symbol must flip because we're dividing by a negative number. So now it's pointing the other way. 3 divided by negative 1 is negative 3. So now x is greater than or equal to negative 3. The greater than or equal to means I'm going to put a filled in, a closed circle on negative 3. Greater than. Okay, so let's see. Are the numbers bigger on the left or the right? Well, if I take a look on the right, numbers are going to negative 2, negative 1, 0, and becoming positive. They're getting larger. So I'm going to point my arrow to the right. Doesn't matter how long your arrow is. It could be as itty-bitty as mine is, as long as it's pointing the right direction. All right, let's do these last two. All right, let's zoom out to, oh my, how many times do I say all right? Someone needs to count that and get back to me. I feel like that's like my word this year. I've said it like 20,000 times, maybe more. Anyways, Anali woke up one morning and decided that she wanted to train for a bike marathon. The function represents Anli's journey as she rode her bike for 20 minutes. She decided that if she was able to ride for 6,000 feet or longer, she would buy a bag of chips as a reward. Let's graph this linear inequality. Okay, so her goal is 6,000. Let's find that on the graph. Here it is. Now let's find where 6,000 happens on the line of the function that represents her journey. So what I'm going to do is I kind of draw a dashed line for myself and extend 6,000. Pretend that is an accurately dashed line, or straighter, I guess. It hits right here. So this is Annalie reaching her goal. But she would buy chips not just for reaching the goal, but for 6,000 or more. So now let's make this pencil a little thicker. I'm going to trace over the or more part. Or more is this way. It's getting larger. So over here is success and bag of chips. Down here is no success, no bag of chips. Number 10. Miguel worked at a local Circuit City during the final weeks before it closed down. At the time, the store only made $4,000 on laptop sales. In order to sell their remaining inventory, Miguel was told that he would get a free laptop if he was able to get the sales to 8,000 or greater during the week. This function represents Miguel's sales. The graph, the linear inequality, that represents when he'll get a free laptop. Okay, so what's Miguel's goal? Miguel's goal is 8,000 or more. Let's find 8,000 on the total sales. There it is. Let's find when on the function of Miguel selling 8,000 happens. So I'm going to make a little dashed line horizontally. Ooh, this one's better than the last graph. Until I hit Miguel's function. All right, beautiful. So it looks like 5 laptops is his goal. But he says 8,000 or greater. Maybe if he does really good, he'll get some extra. I doubt it, but you know what? There's always hope. Or greater happens right here. Or greater. So if Miguel sells 5 or more laptops, he will get his own free laptop. A good deal, however, Miguel is losing his job because Circuit City is closing down. So that kind of sucks too. Anyways, I hope this was helpful. If you have any questions, don't forget to ask me about it. Have a wonderful rest of your day. Bye.